Hey, what's going on, guys? It's Vinny Haunted here with
Joe.
Welcome to the Creation Storming Out podcast, episode number
8.
In this episode, we are going to be discussing that oh so frequently asked, and yes, I knew you guys would ask for it eventually, so this episode is going to be all about the distant starlight problem.
Oh no.
This problem, we'll get into it in a second, but it's one of the most frequently asked questions about astronomy, and there's a reason for that. So in this podcast, we are going to be going through distant starlight, the problem, theories you should not use, and theories that could be possible. There's no really theories that is for sure the one that made distant starlight possible, but and then we're going to last but not least discuss
Big Bang's light travel time problem.
That's right. So we can't wait to get into that. So let's just go ahead and get started. First off, let's talk about the problem. Here's a little equation. D equals VT.
Whatever that means.
Yeah, if you guys scratch your head, it basically means the distance, that's D, equals the velocity times the time. So say you go... You stupid thing.
Okay, that one.
So say you go 120 miles and you go 60 miles an hour for 2 hours, then 60 times 2 is 120, so you go 120 miles. It's an equation that you know, even though you might not know, or you might not think you know. So the problem is that the speed of light, or c, is about 670 million miles an hour. That's too big a amount of time for us to figure out, so we just say 1 light year. That's the distance distance light travels in a year. Doesn't have anything to do with time. So the problem.
That always used to confuse me because I always
the
thought
distance
it was
from the
time.
sun. Yeah, the distance from the sun to the Earth is about 7 light minutes. So it takes 7 minutes for the light from the sun to reach the Earth. But the distance from the Earth to the Andromeda Galaxy, which is the nearest galaxy to us, is about 2 million light years. So you can already see we got a problem here. According to that, it should take about 2 million years for light from the closest galaxy even to reach us. So this is a bit of a problem. So you take our equation, distance equals velocity times time, and you have billions of light years equals the speed of light times billions of years. We got a problem here. This is contrary to scripture.
Oh no.
So now first off, obviously this is not too big of a problem, because we all know that God could make it happen. It's not too hard for him.
But the atheists, when you say, well, God could make it happen, they go, ha! You don't have an answer!
It's funny, the atheists almost never have answers, but if you lack answer once, then you got, then they just, yeah.
Stupid,
so,
stupid,
there are actually
stupid.
some theories that are very possible. That, it's not sure whether we can figure this out, but I think it's very possible that we could, in the future at least, figure out how the distant stars manage to reach us. So, first off, let's go into some theories that you should not use. The first theory questions the distance. So we're questioning the distance in this theory, So, but something you should know: these distances are real. It's true that some aspects of science are skewed by evolutionary ideas, but the distances of distant stars is not one of those. So the other one questions the distance again. It's called the light in transit. So basically the idea is if you have a star and then you have Earth, when God created a star, he also created a beam of light. So the problem with this one is that according to that idea, then like say supernova, things like supernova would have never happened because they just had a picture created of them happening. So this again is a theory which you probably should not use. So let's talk about some theory. This one is really a theory I think is sort of doesn't seem very possible, but it is a simple theory that could be possible, but I don't see any evidence of it really being. This is the CDK, quite literally meaning C, or the speed of light, decay. So the speed of light is decaying over time. So we take this time we're questioning the velocity, the speed. Basically saying that the speed of light used to be much greater than it is today. It's only now slowing down. Now this would be okay if the speed of light had nothing to do with the rest of the universe, but the problem is the speed of light is linked to nature, like this famous equation. You have seen it?
Yep, E equals mc squared.
So that stands for energy equals mass times the speed of light squared. So of course that'd be like 186 million miles per hour.
Yeah.
Squared.
Really?
That's times itself. So it's really big, but that's how you figure out how much energy is in something. But if the speed of light used to be greater, then either the energy or the mass would have had to compromise and get smaller. And, well, to put it simple, that would cause problems. Kind of like if the Earth's mass had gone down, then you'd plummet into the sun.
And we'd have a problem.
Yeah, we have
a big problem.
A big problem.
We'd be getting, it's getting kind of hot.
In my opinion, CDK is really a theory which, just is not one of those. It's too simple. It's too simple. It's too
Atheists would make fun of you about that one too.
So here's some possible theories that are currently being worked out in details. First, you've got gravitational time dilation, or GTD. Basically, this theory says gravity affects time. So, literally, if you here on Earth, you've got when the closer to the center of the Earth, where the gravity is, the slower the time rate goes. So this idea is that Earth time actually goes much slower on Earth than out in space. So distant Starlight would should have enough time to get here in only 6,000 years.
But Vin, does that mean if you take a clock out to space, it'll start going faster?
Yeah.
Very interesting.
So here's another one, the alternate synchrony convention. Bear with me, this is complicated science. The ASC theory basically says, well, this, you might have seen this before. You leave a plane at 4 o'clock, 2 hours later you arrive at your destination at 4 o'clock. How is this possible?
You arrive somewhere else where the time was different?
Yeah, you leave a plane at 4 o'clock local time and arrive 2 hours later at your destination, 4 o'clock local time. So that's because there are time zones here on Earth, because the Earth is round and it's when it's day here on the other side of the Earth, it's night. So we had time zones to figure out different time, and we can do the same thing in space. So basically, the alternate synchrony convention says that light leaves the star on day 4 cosmic local time and arrives day 4 cosmic local time. So it doesn't sound like it makes, but yeah, it's one of those theories which they're working out. And so you have three theories: the speed of light decays over time in CDK, gravity affects time in the gravitation time dilation, and light departs and arrives day 4 in cosmic local time in the alternate synchrony convention. Now, these are not the only theories, but for I figured I'd just cover the basics. No sense in complicating things on only episode number 8.
Nobody'd understand what we were talking about anyway.
So anyway, the Big Bang also has a light travel time problem. So if a Big Banger comes to you and says, I was just it's so stupid. I got a distant starlight problem. You say, yeah, but the Big Bang has a distant starlight problem too. See, during the beginning, according to the Big Bang, parts of the universe were either very hot or very cold. You've got the cosmic microwave background. You ever heard of that? Basically,
those are those things you put the hot dog in and they cook it in like 10 seconds.
No, the cosmic microwave background. Basically, this was like a supposed baby picture of the universe when it first started out. It's basically it's like a, if you could see it, it'd be like, you know, you go in the sky and it'd be glowing with these nice pretty shapes. But apparently, you know, they said, oh, the Big Bang must be true. There's this cosmic microwave background, but the cosmic microwave background wasn't, you know, it wasn't as quite what they expected. See, today the temperatures in the cosmic microwave background are almost completely even. So, you know, same temperature here is same temperature way over there. So light would have had to travel to even out the temperatures, because according to the Big Bang, parts of it were either very hot or very cold. So there's not enough time, even in 4.6 billion years, for this to happen. It's not enough time for it to even out the temperatures. So Big Bang believers also have to make light go faster. So,
but they have a argument. Answer for that. Every single question you ask, every single thing you tell them like that, they just can say that's not true. That's a popular one for atheists. Yeah. That's not true.
Yeah, well, scientific one. Hopefully they don't ignore this one completely. I've actually, there was that, do you remember Morgan Freeman, his movie we watched? They actually very, you know, they very subtly mentioned this one. They say, yeah, there's a horizon problem.
They're like, no, there's a problem, but we don't like to talk about that.
Yeah, well, it's okay, it's okay. It's just a horizon problem. There's no real need to worry about it. So, anyway, the conclusion, distant starlight is not a problem for a young universe. In fact, it's a problem for everybody, pretty much. Even Big Bang believers. So, anyway, now it's time for the most funnest part of this podcast. Oh, wait, I'm sorry. We have one suggested resources. There's only one resource. Oh, well. Distant starlight, not a problem for young universe. It's a DVD from the Answers Mega Conference. That's what I remember, 2006, I think.
And it was made by Dr. Jason Lyon.
PhD. We got a PhD in astrophysics. Maybe one of these days I'll get to go to college and get a PhD in astrophysics.
And I'll stay home and milk the cows.
Yeah, well, whatever. Anyway, now it's time for Creation Astronomy Now news. We get to talk about what's been happening.
The funnest part of the show.
Yeah, we've been working, you know, trying to keep up. It's been hard because Thanksgiving has come, and you know, you gotta cook a big meal, and it take like all week.
And through all this hustle and bustle and hard work, we're trying to be thankful through it all.
Yep. There's a lot to be thankful for, man. I'm thankful that I have this chance to, you know, be able to try to make a difference. And I'm thankful for, you know, the fact that Creation Astronomy Now is growing. You know, it is growing, and I expect it'll keep growing. And you know, doing some stuff with Creationist Company, and making our own productions. And I'm planning on writing some ebooks, and we're working on the Sky Guide 2014, which should be done here in a couple of weeks. Well, then we'll get it up to. I think it's gonna be free this time. I'm working a few of the details out, but you know, here in a couple of years, I hope to be able to get a printed Sky Guide. I'm gonna print it up,
and then people have to pay for it.
Well, you can't do everything for free. But anyway, so yeah, we're coming to the close of a year, and that's always fun. So, you know, the next two podcasts, I'm gonna be doing them all about the closing of the year. First, I'm gonna have one about the greatest astronomical events of 2014. This is 2013.
Yes, it's 2013.
Yeah. The greatest astronomical events of 2013. Pardon me. And then I'm going to have a final podcast of the year talking about the new year. What better subject for the end of the year? So, anyway, this is Vinny Harned.
And Joe.
And I will see you in the next episode.
Which will be episode 9.
See you guys.